to our Azure Active Directory series, using Azure Active Directory to secure your apps. My name is Paul Schaeflein, and I'm your presenter today. As I mentioned, this is a series of presentations that we're doing. Part 1 was recorded 2 weeks ago. It's available on the IT Unity website, as will the rest of the series, and once we get done. Part 2, Integrating Azure Active Directory, is the one we're here today. And in 2 weeks, we'll be doing Advanced Azure Active Directory topics. Hey, my name is Paul Schaeflein. I am a longtime SharePoint solution architect and developer. I've been doing this for quite some time, and have moved up into Azure and Office 365 recently. I do a lot of speaking at events. I hope to see you at events in the future. I do training as well. And thanks to Microsoft, I've been awarded the MVP award, previously in SharePoint Server, but currently Office 365. So today we're going to talk about getting down into the nuts and bolts of integrating Azure Active Directory into your application. We're going to cover 3 different approaches of how we work with Azure AD. First, we'll talk about using Azure Active Directory to secure a web application. This is by far the most popular integration point. We have an application running on a web server somewhere. It could be in the cloud, it could be on premises, could be on local machine. Either way, we want to secure access to that using Azure AD, and so we'll cover that. Another option to do is to secure a service. By service, I'm referring to generally a service available over HTTP, which and these days might be WebAPI or a OData service. You could use it as well for any type of communications as well. Anything that can support the OAuth standard, so we'll cover that. And then we'll touch a little bit on consuming one of those services that's secured by Azure AD. And if time allows, we'll do both web-based and native application, but I'm going to focus primarily on the web-based stuff at the moment. What we're seeing is a lot of cloud-hosted or web scenarios, but we'll try to get into the native application side. And then we should have some time for Q&A. In the webinar software, there's a section for questions, so you can type in questions. I'll keep an eye on it as we go along. If the question is somewhat relevant to the current slide, I'll try to loop in the answer. If it's not relevant, I may defer them and wait till the end. And in the event, you're free to contact me through the IT Unity website as well. We'll try to get questions answered for you. The goal is to make sure you can move forward with your applications. All right, so let's get started. We're going to talk about the different types of scenarios that we want to cover here. And so this is a graphic that came from the Azure Active Directory documentation, which of course I have a bunch of resources in the slide deck. We'll get that to you. But you can see here that we have many different types of scenarios. On the left-hand side, you'll see generally the execution environment of the application. So we're talking about either a browser-based application or a single-page application. We have native or mobile client, and what we mean there is something that's using iOS or Android or Windows. Not typically a browser, but just some other type of device. And at the bottom is what they call a daemon or device. That first word, D-A-E-M-O-N, is a Linux or Unix term, which is generally an unattended process. So you can think of it as a scheduled task in Windows, that's something, or a Windows service that might be running without a user interface. All 3 of those are supported, you can see here, in part of the Azure AD scenarios, right? And so you can have a browser which is calling a web server, or a browser is calling a web API if it's doing an AJAX call. Native clients typically wouldn't be calling a web application, nor would services, because they're calling an API. And obviously you can have a web application call a web API, or a web API call a different one. So if you're trying to have your custom service that's reaching out to Office 365, for example. So you can see these scenarios where there's what we call hops, many different transitions from one execution environment to another, typically over HTTPS. And Azure Active Directory and some of the industry protocols are designed to facilitate communication so that happens in a secure manner. We don't want someone connecting to Office 365 and reading our documents unless they actually work in our company. We've given them permissions to do so. And so you can do the same scenarios in your own custom applications. So how do we go about doing that, right? So what we're going to focus right now is the first one is we're talking the browser communicating with a web application, right? So the single-page application scenario is a little bit more involved. We don't have time to cover that. There's some prior art on that as well. You can review. Andrew Connell has written an article on IP Unity to cover that scenario to get you started there. So we're just going to focus on browser communicating with a web application. Right? And so what does it mean to secure a web application? And so the first thing we would talk about is called we only certain users to access that application. This process is called authorization, sometimes abbreviated auth-z. And again, this is we only want certain people to access this. It's not anonymous. In addition, some applications will have different roles. For example, you could have an accounting application that has accounts payable and accounts receivable. So you only want certain people to spend money, and anybody can receive money. And so that process is what we call authentication, also abbreviated auth-n. And this is again the process that happens inside the application. And so a key thing to keep in mind is that no matter what's happening here, we want to know who or what, and this is what we call a security principle. And so security principle is the term that is used to identify, or a generic term, right? And as you can see here, it could be a user, it could be a group. Inside of SharePoint, we have SharePoint groups, but it could be a SharePoint group or an Active Directory group. A lot of people will create service accounts. A service account really is a user account, but perhaps no user. It's not assigned to a human. That's what these daemon processes would run. Sometimes we can have that as well. And in these recent changes in SharePoint 2013 and in Office 365 and with these new authentication protocols we have recently, we have this concept of an application being a security principle. An application can request a set of permissions and be granted that set of permissions to do things independent of the user. And obviously as a developer, you can decide whether you're going to allow users to access your application, you want to have other applications access it, do you want to have permissions that are subject to the current user in addition to the application, or do you want what we call app-only process, so that if an application makes a call to your service, do you care who the user is? In some scenarios you may not care who the user is, you just want to move through. And so we know we have these things, these principles again, and so here's just a recap. So we have authentication, and this is auth-n. Again, this slide is telling you what we call these definitions using the identity management terms, right? So the process of verifying the principal's identity. And the key point here, it's not the user's identity, it's the principal's identity. So we still have authentication in effect for users, for groups, for service accounts, and as well as applications. And again, once we know who the principal is, then we can decide which resource that principal can access. As I stated, the who performs these different activities is different, right? And so as you go through this little flow chart, you'll see we start and we're inside our application. And then you can see there's typically the infrastructure performs authentication. The logon happens by or is enforced by some sort of infrastructure, and if that is a valid response, then it's returned back to the application, who can then go through and allow to execute a particular function. And so in the web space or in the Microsoft stack, this infrastructure authentication has typically been integrated Windows and TLM. Now, it is possible to use forms-based authentication, or what we call ASP.NET Identity Application, in which case the application itself may be doing the authentication. However, I didn't include that on the slide because it's really, with these new protocols and the standards we have in the modern development approaches today, there's really no reason for your application to be doing this authentication. You really should delegate that to some other source. And so what we're seeing in the cloud space these days is that the infrastructure may be something that's external to your environment, and specifically what we're talking about in this series, that infrastructure is the cloud-hosted identity management service called Azure Active Directory. So the application just says, hey, go somewhere else and log in, and when you come back, you're going to have a ticket that says the logon is valid, or the tickets will say logon is not valid. And based on that decision, I will then move forward. And so that's the process that we have. Here again is a recap of these common authentication methods that we have seen traditionally, right? So integrated Windows NT, forms-based authentication, which legacy code is probably using .NET membership. There is a newer version of that called ASP.NET Identity. The key difference there being that ASP.NET Identity, the current one, is claims aware, so it can handle some of the more advanced scenarios. The claims-based authentication is what we see starting in the last 5 years or so, and obviously we have an option to do anonymous logins. Right? So when we are using cloud-hosted application, or we're writing applications that we expect to execute in the cloud, integrated NTLM is not going to work. Now, I preface this by saying you could be in what they call a managed cloud, and I have many clients that have said, well, we have a data center is run by a third party and they're hosting servers for us. And so in that case, you can use integrated NTLM because there are servers that you can configure a directory. But typically that's not an option, especially if you're going to be leveraging Azure Active Directory or some other source. Again, FBA requires a lot of work, but for the developer has to have some type of interface, management interface, to say, how do I add users, how do I assign users into groups or assign users to roles, and manage all that. On top of that, it's a higher risk. Is the code that you wrote to authenticate users secure? Do you have gaps? Have you tested it against the penetration testing and so on? What about where you're storing passwords? Have you done penetration testing on that? Have you leveraging best practices in that regard? And so I like to tell people, are you willing to take that risk? Do you want to be the next company that we read about in the news that has had a breach and now usernames and passwords are all over the internet? Is that really something you want to take on? And in many cases, because as you'll see here, we can go through a couple clicks or do a certain approach in our code, we can then outsource this identity management, this password management, the authentication task to somebody else who's much better at it than I am. And so why would you want to take on that risk? Claims-based authentication is our current standard. This is what we're doing, right? So this is the generic term for all the things that we do these days in the web. And as we go through a bunch of the acronyms, you'll see I mean, they have different names, but it really all is the same. There is a claim embedded inside here, and we're going to be doing that. Anonymous, well, clearly, if we're not, we don't authenticate users, so we don't necessarily worry about that so much in the cloud, right? So claims-based authentication typically has been confusing to developers, but I like to say, you know what? There are claims in real life, and so a popular scenario here in the United States is, if I'm going to do some work, they say, well, we need to have proof that you're allowed to do work in the United States. Do you have a visa? Are you a citizen? And so I fill out a form, and then I need to verify that I am. So in my particular case, I have a U.S. passport, so I can say I'm allowed to work in the United States. Here is my passport. Well, what does that mean, right? So if you look at the passport has a page that has my picture, it has my name, it has a passport number, it has date, expiration dates, it has information about me. We call those attributes. Or claims. I'm claiming to be Paul. My passport says I'm Paul. But the key difference is the passport was issued by the United States State Department. And so employers who are based in the United States trust that the State Department wouldn't issue a passport to someone whose the information is not true. And so you can see here there are claims about me being backed by some authority. Similar concept, if I'm going to, in many states, the United States, you can't buy alcohol unless you've reached a certain age. Well, every place that sells alcohol is not going to be validating. How do they validate people's age? Well, they don't. They rely on some form of identifier, a government ID. Taking this out of the physical world and into the virtual world, you'll see often where I can go to sites that say log in with Facebook. And if I click that button, I log in with Facebook and then I come back to the site. Well, so again, the same concept is happening here. A site decides they're not going to be validating credentials. They'll say, hey, you go to Facebook, and they work with Facebook to establish a trust between the application and Facebook. And when the user logs in with Facebook, they get a ticket that comes back. We call that a token issued by Facebook, and it has information about the user. Here's the first name, here's the last name. Maybe it has friends, maybe it has a news feed, whatever the case may be. But we're seeing this happen all the time, in which someone who wants to have some type of non-anonymous access, they're delegating or relying on a different party to do that authentication for them, to verify who this person is. And those are the concepts that we're really talking about when we're doing this external cloud-based authentication. How do we do this? Right, this is always a part here that is tough to do. And so we're going to talk a little bit about the protocols that exist in libraries that will help you do this, right? So, because who wants to write all this code if we don't have to? So when we're authenticating users, the key thing here is that we want to externalize our authentication. You should not be using ASP.NET membership anymore. Again, we talked about that. The risks outweigh the benefits. And so the task is, with using the identity management terms, is that we are going to delegate our authentication to an identity provider. An identity provider is somebody that issues a token that contains claims. The identity provider in my scenarios, this U.S. State Department, has a passport that has information about that. Facebook provides information about my friends and my name. And so I configure my application to delegate authentication to an identity provider that I trust. And then that identity provider returns a token that contains a bunch of claims, and I can then use those claims to make authorization decisions. By far the most popular claim that anyone would ever get is a group membership claim. So this user is in the accounting group or the executive group, and so that's what we typically have done in the past, is by looking at group membership, and that's what we're talking about with claims authorization decisions. So how do we do this, right? Clearly this has been around for quite a while, and there are two primary user authentication protocols. The first, or what we would call legacy these days, is called Web Services Federation, or abbreviated WS-Fed. This is a XML-based SOAP transaction format that is based on what we call SAML, Security Assertion Markup Language. This is a schema of XML that will then, this token that gets passed back and forth between systems is an XML document that has the information about the claims, right? It's asserting security information about the current user. WS-Fed or SAML tokens are issued by many providers, the most popular in the Microsoft stack being Azure Access Control Services, as well as Active Directory Federation Services, or ADFS. ADFS is software that you can run on premises. Azure Access Control Services runs in the cloud. Again, that's XML-based. It uses the SOAP transport protocol, so there's a lot of overhead in there. SOAP messages, not necessarily germane to our topic, but SOAP conversations are synchronous, and so that I make a request and I get a response, and there's some guaranteed delivery in there. And sometimes that's not really important. If someone tries to log in and I never get a response from the identity provider, does my code need to do anything? Typically not. If it just times out, then the user can log in again. So there you can see there's, in many cases, there's not necessarily a need to have all the overhead of a SOAP transaction. And so the industry created what was called OpenID, and now we've moved on to what we call OpenIDConnect. OpenIDConnect, written for the internet, written for HTTPS RESTful conversations. Instead of using XML dialect, it uses a JSON web token, or called JWT, which we pronounce JOT. So I get a JOT token that uses JSON data formatting instead of XML, so it's a little smaller data packet. And then it uses basic REST calls, so I make a HTTP request and I get a response. I don't have to send a SOAP envelope and have to worry about all that overhead. We have different providers for OpenIDConnect, so of primary importance in this series is our Azure Active Directory. So Azure AD can issue JOT tokens based on OpenIDConnect protocol. In addition, all the social networks do that, Twitter, Facebook, Google, and more. There's many things that do that. So I have plenty of options that I wish to delegate my identity to. The decision for what provider am I going to use has many different considerations, and what we're seeing in this primarily Microsoft stack is if I have an on-premises Active Directory, I can install a synchronization tool on my network that will then synchronize my users up into the cloud directory. So when my users are at home and they want to log in, I can redirect them to Azure Active Directory, and they can use their same password in both scenarios. So that's why we see a lot of uptake on this Azure Active Directory as the provider, because it's much easier on the users. I don't have them writing passwords for many different places. So these are our protocols that we can do. We don't necessarily have to write all this code from scratch. There are libraries available to us to do these. And again, we have them for both. So I apologize for the typo there, but it's a WS-Fed. SAML has a library called Windows Identity Foundation. This is what SharePoint 2013 is using on premises. This is what many of the legacy providers are doing. There is a system.identity model or system.security.claims namespaces. They have a bunch of libraries that will go through and do that conversation. Rather than have to write all the code to make the conversation between servers, it'll do that for us. Visual Studio, both versions of the Visual Studio 2013 as well as Visual Studio 2015, have a button in the new project dialog that lets me configure that, or I can provide the relevant information, and Visual Studio will do a lot of the bootstrapping for me to get this libraries included in my project. And we'll see that in a little bit here. For OpenIDConnect, the library that we use in the Microsoft stack is called the Active Directory Authentication Library. This is built on top of the Windows Identity Foundation, which you would expect, right? And so ADAL, as it's called, is not just .NET based. However, they have managed libraries for .NET. They have JavaScript libraries, and there is work underway to make these work with any languages that are necessary. But at the end of the day, it's HTTP calls happening, so it's supported by many platforms, and the Azure Active Directory team is certainly interested in connecting to all those. So there are more and more libraries coming on board for various different environments based on where you write your code, what language you use. And Visual Studio 2015 has project templates that include OpenIDConnect. They didn't retrofit Visual Studio 2013 with some of these, although to be honest, I haven't installed Visual Studio 2013 Update 5, which came out a few months back, so it may be in there as well. But what we're seeing is if we're doing OpenIDConnect, the Visual Studio 2015, which is very simple to get, the community versions are free, you can at least get started on that. And that's what we'll see here when we talk about, go through a demo here. So that's a little overview of what this authentication means, outsourcing it to identity provider. Let's talk specifics. When we're in Azure Active Directory, this is a big picture of what's going to happen here. We have a user who's trying to log in, and they have our web application. Azure Active Directory is involved. There is a sign-in page, and I want you to note that the sign-in page is next to Azure Active Directory. We've outsourced, or we've delegated our identity or our authentication, so sign-in happens somewhere else. I don't have to worry about that myself. And you can see there's lots of arrows back and forth, but I want to walk through a little sequence diagram that covers what this process is happening. So we start, a user navigates to your web application. Your web application is configured to have authentication performed by Azure. So your application returns a sign-in request, right, including an identifier of your application. And it goes back to the browser. And then it includes a set of JavaScript that then redirects the user to Azure Active Directory. So you can see here we're at the WS-Fed or SAML endpoint. Again, I'm authenticating a user. We use OpenIDConnect or SAML or WS Federation. So when the user signs in, Azure Active Directory then returns a packet to the browser, including script that will then post a token to the reply URL that's configured in Azure Active Directory. Key thing to point out here, in order for this to happen, the web application first registers with Azure and says, anyone who requests information from me, you send them to this URL. And so if a request comes in, Azure doesn't ask where should you go, it's going to send them to a specific place. That way we can be certain that the responses coming to us are valid. Included in that response is the token, and the token is cryptographically signed, and it has the information, so again, we can validate the token, make sure everything is good. If we make sure that there hasn't been any man-in-the-middle tampering, anything like that, then the application can say, okay, I know who the user is. I've now established a session, and we would typically maintain session or information about that using cookies. And so there's an auth cookie that then gets set in the user's browser, and life goes on, right? So now you've established this identity based on Azure Active Directory. This is the flow that happens behind the scenes. Let's go through real quick and see how we can make that work. So I'm going to switch over to Visual Studio 2015. So in Visual Studio 2015, I'm going to just click New Project at the moment. And so in here, I'm going to choose a web project, ASP.NET application. And so, again, I'm not going to put a big name on there. And now we get our new template, right? Our select project template. So for the moment, I'm just going to go with an MVC4. Obviously, there is a preview version available of other things, but I'm going to choose that. But on the right-hand side, you'll notice is right in the middle here, there is a button that's going to let us change authentication. So I'm going to click on that, and I get this dialog. So if you remember back in my slides, I listed the types of authentication. Windows authentication, Windows NTLM. I can configure my app to do that. I can configure it anonymous. Individual user accounts is that forms-based authentication or ASP.NET identity. But what they're saying here is this: is that you have user profiles stored in a SQL Server database, and you can sign in using the social accounts here. So the key part here is I can choose to do the authentication myself like I had to, but I don't really tell you Microsoft has gone that way. We're not telling you that. But in addition, this is how I can outsource my identity to one of the social providers. And the expectation is that when I get information back from Facebook or from Twitter, the user account that I get back, it might be my Twitter handle, but it might be an identifier. So how are you going to correlate different people into your application? And you still want to have information about your users that you have to store yourself. What we're concerned about today is called work and school accounts. So when I do this, this is Azure Active, either on-premises Active Directory, ADFS 2016 will do that, or Microsoft Azure Active Directory. I'm going to enter in my tenant here. So I want to choose a couple things to point out here. So I can have a single organization or multiple organizations. I'm going to cover the single organization here. You are writing applications for your company. If you're an independent software vendor, you'd be doing multi-tenant. It's a little bit different, but the concepts are the same. And then I can choose whether I'm going to let my application, I'm going to request, do I want to be able to read directory data? And you typically will, because if you want to know the group membership of this person, you may want to do that. Obviously, if I have an existing ID, I can specify that, but I don't for the moment. I'm just going to click OK. And Visual Studio will then say, okay, you want to talk to that Azure Active Directory tenant. I said before, the application needs to be registered inside the directory. And so in order to do that, I need to have credentials to log into that directory. And so Visual Studio will then go through, and behind the scenes, it's actually communicating with Azure Active Directory, registering my application. It shows me that here. I'm finally good. I can click OK. We'll let Visual Studio go through and do its thing. What I'm going to do here is I'm going to open up a browser. And in this browser window, I'm going to then navigate to my Azure portal. So it's manage.windowsazure.com. And so I'm going to log in using that same account that I just used here. So that's this administrator account here. And I log in with this account. And so now I'm in the Azure Management Portable. We covered this in depth in the previous part 1 a couple weeks back. But if I look now in applications, I should see an application called Web Application 2. So I'm going to come back in here, and I look, and here's Web Application 2. And so Web Application 2 was registered in my directory by Visual Studio. You'll notice there is an ID and a key. I can't see the key in the portal, but here's my ID. It's 08 Delta 9. I'm going to flip over to Visual Studio and look in Web Config, and if I look at the client ID, it's a little different. So something didn't work quite right here, right? Well, the idea here is that I probably already had a Web Application 2. So I'm going to go right-click on this again, and I'm going to choose Configure Azure AD Authentication again. And this is new to Visual Studio 2015 that we'll go through and say, hey, you had this already, right? So by the way, here's my client ID and all this information. This is what's configured, right? So something's going on in my portal. I'm going to click OK, click Next here. It'll verify. It gives me the secret. Again, I finish. So Visual Studio 2015 will let us rerun this, right? So I'm just going to let this finish here. I'll show the yes all. And so basically, I reran that new project wizard again. And so right now, I'm going to just go through and run this application. You don't have to use Visual Studio to register these applications. We covered that in the first part of the talk. But here I make, it does a lot of this work for me. And what you would typically expect is in development, you would just let the wizard do it. And then when it comes time to go to production, you would go through and do the registration manually. So again, I'm going to log in, admin, and it's just going to click sign in here. And now I'm getting what we call common consent. And so this is a capability of Azure Active Directory that says, hey, administrator, you want to log in with this application. And that application has said it wants to read the directory data, and it wants to sign in as you and read your profile. Do you want to let that happen? We see this when we log in using Facebook or Twitter. We get those, do you want to let this application read information, right? So I'm going to click accept, and when I do that, you'll notice here, by the way, I launched my application in Visual Studio. The first thing I saw was the Azure login page. But then I'm going to connect up. You'll see here that it's running rather slowly with the login.microsoftonline.com account. When this is done, it's not redirected to my application. So my application's not involved until the user has logged in. And you can see here I have hello admin, right, so I can see that information. So since the point here is not to cover ASP.NET MVC, I'm not going to go through the whole application, but what I will do now is open up some code so you can see what's happening. This is an ASP.NET MVC application that I chose. ASP.NET has configuration information in web.config, and you can see here I have my client ID, I have an Azure Active Directory tenant ID, I can have a client secret. This information is stored in web.config by default. You may want to encrypt this section of web config in production or move that code somewhere else, but that's where we see things to begin with. Now, in MVC, when an application starts, we have the app start folder. And so in the, the startup.cs class, and you can see this calls into configure auth. And configure auth is going to come in through here. And one of the things that we're going to start up is the authentication. So this class, startup.auth.cs, is added to our project as part of the Visual Studio template. And this is where the login happens. And so MVC is configured to not allow anonymous, right? So this configuration is going to say that the sign-in authentication type is by a cookie. So if you don't have a cookie, then you need to log in, right? That's plain. Doesn't matter what your authentication provider or your identity provider is. We're using cookie authentication. Okay. And using, this is the Open Web Interface for .NET, or OWIN is what it's called. And so we have cookie authentication, and on top of that, we want to use OpenIDConnect. This is the libraries that get added for us as part of the Bootstrap project. This is Microsoft.identity model, .clients, .active directory. And then there's a helper one here that has a bunch of extensions, which would be the OpenIDConnect protocol. Right? So you can see here, this is the libraries provided for us in this OpenIDConnect authentication notifications class. And so what the paradigm that Microsoft has created is that events fire as the authentication happens. And so what we're configuring here is say, hey, we want to plug into this pipeline, and when a code is received from the identity provider, I want you to run some code. And the code that we're running here is just your plain create a cookie. So you can see here I have, this application needs to communicate with it's going to redirect the user to Azure Active Directory. Right? And so what we're sending here is, you can see here I have a client credential, and notice the client credential is information about this app. Our application is going to have, it has an ID, it has a secret, it's going to authenticate with Azure Active Directory and say, hey, I want to make sure that you know who I am, so that when the response comes in, you get redirected back to my site. I'm going to flip back over to the Azure portal again, and you'll see here I have a reply URL. This is where Azure Active Directory will send users when the request is completed. How does it know which application is trying to log in? I have a whole bunch of them here because my application sends this client ID and the key. And so in addition here, this pipeline, when it runs here, you'll see here that I have this context, right? So if I come back up here, my context is this OpenIDConnect authentication context. And you can see here that context has we'll call a ticket or a token. In that token, we'll have various different claims. I want to find a name identifier claim, which would typically be your email address, or maybe your SAM account name, whatever you've configured. And so I can pull out the name of the user. I have my application, and so I can create what we call an authentication context in here, right? And what we're doing in this particular scenario here is they're caching these into a in-memory database, so I can do this response one at a time. Remember we said this is cookie-based, and so what we're remembering is that, hey, I have a collection of claims that came from Azure Active Directory. I'm going to store them locally in a database, and part of that key to this token cache is going to be the name identifier. So Paul will have a cookie that is the unique identifier of this local database, and then on subsequent requests, when I get the cookie, I can look up information in this token cache. Again, this is code that happens for us automatically. I don't have to worry about it. It's done, taken care of. Just to wrap this up inside of MVC, my home controller, you can see here I have the authorized attribute set on this controller. So anonymous users are not allowed. That's part of the MVC. It works automatically for us. There is an account controller they give us as well, and that was what, at the top it had my name. You can see here where I can, notice here, by the way, there's no authorized a link here, right? So I could have a controller do a sign-in page, and when I do sign-in, if I'm not authenticated, I'm going to go through and say, hey, I want you to go and find out who this user is by issuing an authentication challenge, which would be a 301. No, a 401. Sorry, I always get those confused. It'll send the 401, and then it'll come through and say, I want you to go, and when you come back, redirect to my root path, which would be my home controller. And so by setting this, it's telling us, hey, go get whoever is plugged into my authentication, right? OpenID. I'm telling this OWIN context, I want to use OpenIDConnect for my authentication. And that's all the code I need to do to force the user to go log in. This sign-in controller gets executed. It does this code here. This will return a redirect to Azure Active Directory based on the information in here. And so that's all I need to do. That code is pretty much straightforward, and as we saw that working. Again, this is authenticating users. I'm going to go real quick over to Visual Studio 2013 just to show you the difference here. If you're using Visual Studio 2013, we have a similar wizard. When I do a new web application, I still have this change authentication here, right? And you can see here I have the same 4 options. It's called organizational accounts, same screen here. Under the covers, however, we get a different snippet of code, and I'll show you this in a slide because I'm running out of time. The difference is in Visual Studio 2013, I cannot right-click on the project and rerun this with selection. So in the interest of time, I'm going to switch back over to the slides to show you. Here's the OpenIDConnect stuff I showed you in Visual Studio 2015, right? And you can see here it's configuring the authentication. I'm using cookies and so on. This is WF Windows Identity Foundation classes that use WFED in Visual Studio 2013. The difference here is that it's using the federated metadata location to go through and do that. And so there's a lot more code. This is kind of a snippet. You'll notice I don't have this won't compile. It's not syntactically correct. But the difference is, the point here is that when Visual Studio 2013 was first released, OpenIDConnect wasn't an option. So you'll get that legacy WFED stuff in Visual Studio 2013. So that's how I authenticate my users. I have an application, and I'm securing the application so that only users that I allow can come in and execute my code. But a lot of what we're writing today is services. There's not necessarily a human involved in calling a service. I can have an application that then calls into a service. And so I want to secure my service. All right, the scenario we're talking about here is a web application calling WebAPI is typically what we would see, or it could be the native client coming in as well. We have different pieces to the puzzle now. Before it was rather simple. We had the user, we had the browser, we had Azure. Now we have a lot more pieces. We have the user who's going to then navigate to a web application. That web application, assuming it doesn't allow anonymous, is going to call back and say, hey, you need to go log in, right? So the same process happens where the user signs into the Azure AD authorization endpoint, right? This is the same endpoint we saw in the previous swim lane. That returns, part of that request, by the way, is saying, hey, this web application is going to want to talk to the web API. And so in order to talk to the web API, I need to have some type of code. Right, and so part of that request to sign in also says, by the way, sign in, but in addition to signing in, I want a code for my web API. And so Azure Active Directory will, that goes along as the packet back and forth. And after the user is logged in, the ID token is returned. But in addition, a code is returned. And this code is applicable to that web API. The session is started as we would expect. The user goes through and wants to do some work. And now it's time for the web application, my code, my MVC app or my web form app to make a call to the web API. In order to make that call to the web API, I need to have a code. I need to have a ticket, if you will, or a token. So my web application takes that code that was issued at the very beginning, and it sends that code to the token endpoint, along with the client ID and the credentials of the application. And Azure AD will then verify that information and will return what we call an access token and a refresh token. That access token allows my web application to make a call to the web API endpoint. That token is included in the auth header. It's called bearer token, and the web API can then validate that token, and if it's valid, it'll return data back to the web application, which can then return the data back to the browser. So you can see here there's additional steps involved, just as you would expect. I have the user authentication, but in addition, I need to have my web application communicate with Azure Active Directory and get what we call a code to go into the service. So what does that look like in real life? So a couple things I want to show you here. So I'm going to open up a pre-built solution here. Again, trying to talk about how to build all these pieces. We're just worried so much at the moment about the Azure AD pieces. And so this is a collection of Azure AD samples that you can certainly, they're in the resources that are linked in here. So I'm going to open this up real quick, and this is that sample, what we're talking about, where I have a web application connecting to a web API. So let me walk through this real quick here. So there's two pieces here. I have a list service and a web application. Right, so first let's look at the service. You'll notice the service is web API. I have web config. Web config has information. This stuff has been registered with, well, the sample hasn't been registered with it. So let me go through and do that real quick. I can configure Azure AD authentication. I want to create a new my domain. Pick the one that we have. And then this app ID URI, that is going to be a unique identifier. And it's going to go through and add the information. That's good. Finish. And so it's creating my information here. Yep. Okay. So I don't need the information. So now we've done that. I now have information about this. Now if I look at web.config, you'll see I have all the information added to there. There's my code that we saw before. Now here's another thing that's going to happen here. In this particular example from the sample is having, who do you trust to call me? This is an optional thing, so I'm not going to go in depth, but this is just an option that they did to go through and say, hey, this is how I want to have that authentication happen. Here's my auth configuration for this web service. You can see here it's the same thing. I'm using Windows Azure Active Directory bearer authentication. So remember, a service doesn't necessarily worry so much about who the user is. We don't have a user. We may not have a human at the other end of the wire to talk to, and so this is what we call bearer authentication. So I'm saying if someone has a token that's from Azure Active Directory and it has my audience configured with it, I allow that to happen. So I'm using what we call bearer authentication. And so again, this is all we can do for our to-do list service. Now, if I go over to Azure Active Directory and I have my to-do list service, you'll see here it looks very similar. I have a app ID. I have a client ID. Notice that there's no keys at the moment here because my to-do list service isn't communicating to Azure to say, give me something. It's providing something. So it's a little bit different in there, right? And so I'll go back to Visual Studio and we'll take a look at the web application. This is similar to what we saw before. I have web config that will have the information, client ID and client secret. Right? So that's what I'd expect there as well. And in addition, if I look through here, and I have my to-do list controller. Right? The whole point of this application is to read a to-do list. And so you can see in my to-do list controller, I'm going to get information about the client of this application. Because remember, this application is going to talk to Azure AD. And then once I have information about that, if I come down here, you'll see here that we create an authentication context. Right? The authority would be Azure, and I have a credential, which is this application, client ID and secret of this application. And then when it comes time to actually go get the to-do list, you'll see here we can call into the library and say, I want you to acquire a token. And the token should apply to a resource ID. And the resource ID is going to be, again, the thing, what that would end up being, if I go back to here, this would be my resource ID. I want to get a code for the to-do list service, and I want to get that authentication code. So that is my authentication context. And the client credential is this application. This acquire token method, part of the ADAL library, will do that conversation to get the token back, right? And so you can see that's my result. And if you see further down, when it comes time to actually retrieve the to-do list using an HTTP request, which you would typically expect for a web service, you'll see here at line 127, we're just adding a HTTP header that has the authorization name, and the value is bearer space result dot access token. And so the code behind of my MVC application will communicate with Azure Active Directory to get a token that's intended for the service, and then it'll send that token to the service to get the data. That's the core of this application here, right? And this, again, this is us having to go through and configure our service to use Azure Active Directory or configure our application. Now, I want to real quick, before I forget, I'm going to come back into my Azure Active Directory, and I'm on the Applications tab, and I can click Add, and you'll see here I get a wizard. So if I want to do this without Visual Studio, let's say I'm going to do this in a separate tenant, which would be for production, I'm going to choose a web application and or web API, and here's the information that where should users be sent after they log in. And again, this can be any URL that's accessible by the human. I'm sorry, by the browser. And then we need a unique identifier. And so you can see here this in my service, this used my domain name. This is a URI, which is just an identifier. It doesn't have to be a valid URL. So I typically do URI.my domain, just to make sure it's unique, right? Slash. Something like that. That gets me in. This is a valid URI, and that's it. I've now configured another, or registered another application in my directory. And now once I've done that, I can go to the Configure tab, and this is the place where I can go through and see what the ID is, generate a key if I want to do that, and then go through and configure that information, okay? One other thing I want to show you, I'm going to return back to my to-do list web application. At the very bottom of the configuration screen for these applications is a set of permissions. And you'll notice this application has access to the to-do list. This is another ability that is required as part of this code that goes through and will come up here and do this acquire token. In order for ADAL to acquire the token, it's going to inspect the directory to see, does my current application that I've logged in with an ID and key, does this current application have access to the thing I'm trying to read, the to-do list? And you can see here, out of the box, I get just this to-do list service, but I can extend that using some XML. So in this multi-application scenario, you can permission these as necessary. And this is the same factor that you'll see if I were to click Add Application. You would see here's where Office 365 is, right? I can just flip this over, and by choosing that, you'll see it'll list all the applications in my to-do list service, which you saw me register it twice, so you can see it's in there with two different codes. But this is how I can go through and make sure that my service is secure, and I can then control who's allowed to access my service. Now, one thing to point out, I'm going to go back to the service, and so if you saw this button here, if I expect this service to be used by many different people, I want to open it to the internet for everybody, I might need to configure that to be multi-tenant, in which case things are a little bit different. That permission grant shows up in the catalog and so on, so it's a little bit different. It's completely possible, but again, a little outside the scope of what I want to cover today. So, just to recap here, Azure Active Directory uses bearer tokens, and this is how I configure my service to say I want to use bearer token authentication. Last thing I want to talk about, consuming the service, right? We went through this a little bit in the code. This is using OAuth 2 under the covers. This is what's happening here. You can see here I get an authentication context established with authority. In this case, authority would be Azure Active Directory. I create a client credential, and in this scenario, the client is my application, so I use my client ID and my key. And then you can see I acquire a token using a specific resource, which in this case is the list. And then once I have the token, I can put that in my bearer, in my authentication header as a bearer token. Okay? And so before I get to resources here, I got about 5 more minutes. One real quick here I want to go through here, and it's quite possible to do this in native code as well. So let me open up that sample, which I'll cover the samples in just a minute. So here's a native client application. In a Windows Store application is the one that I grabbed here because I'm running on Windows 8. And in this particular solution, you'll see here that the service is included again, but in addition, I have a Windows 8 application, Windows 8.1. And in the main page is my code to come in here. And if you look here, if I look at the references, you'll see I still have Microsoft.IdentityModel.client. This is the ADEL library I was talking about. There's a managed version for the Windows Store applications. And if you look at this code, you'll see it looks very familiar. I'm going to acquire a token. In this particular example, it's making an async call, because if I'm on a Windows, I want to do that. But again, I have the resource and I have my client ID, and so you can see here I'm going to acquire the token. If it's not, if it fails, I can say that. If it works, what ends up happening is that I will get this in this result. I will have the token. So if I come down here and get my source, where I come up and I build my HTTP, you can see here I'm going to add it to the header, the bearer token, that same thing, right? So the code works the same way inside a native client application as it does in a web application. Again, we've abstracted this all the way. We're just making calls to a helper library that Microsoft provides to us. So there's a lot of resources here I want to point out to you, and I'll go through these real quick to give you an idea of what they are, and then you're clear to get these. So first of all, the notable people in this space, right? So Vittorio Bertocci is a senior program manager at Microsoft for the Microsoft Identity Space All Up. He's got a great blog that covers information. He announces new features at Azure Active Directory. A couple of non-Microsoft people that I strongly recommend are Dominic Baer and Brock Allen. The two of them have put together an open source server called Identity Server, which is a replacement of Azure Active Directory, if you will, if you really want to do authentication on premises. I strongly recommend touch base with those two. Here is the one link if you want to remember anything. One thing to take away is the Azure Active Directory Developers Guide, and this aka.ms/AADdev, and you know what, I'm going to launch that one real quick here just to give you that. Because this is our launching point. Apologies for not having this up ahead of time. But this is, again, the launching point of everything that talks about how it works, quick start guides on how to get to with all the different platforms and languages, how to do things. And over here on the left, you'll see I have a quick table of contents. Lots of information to get you started on how to do things. Okay, including discussion of different protocols and some videos and so on. Right? So that's a great place to start. Now, the swim lane charts that I gave you here are these authentication scenarios. And remember, I showed you there was a lot of different arrows pointing, and I covered just 2 of the various possibilities. That's all spelled out in the authentication scenarios. All the various libraries are available online. And then I have a link there to their code sample page, which will let you choose the scenario that you're interested in writing, and they give you a link to GitHub. All these samples are available on GitHub. I just showed you a couple that I just pulled down from GitHub, and you notice I just press F5 and run the wizard, and off we go. So it works real well. Now, in about the last month or so, there's been an update to the app model, as they're calling it, for Azure Active Directory. And so there is a couple things going on. Stuart Kwan did an interview on the Microsoft Cloud Show podcast that talks about this converged account model. And so the idea here is that work and organization accounts or Microsoft accounts or individual accounts, they're trying to converge the experience there. So as a developer, you can make a call to a single endpoint. As a user, you just type in your email address and they figure out what you need to happen. There's information about that. But in addition to that app model, so there's some changes there. And so at the moment, the libraries haven't changed, but you can expect those libraries to change in the future. And Rich DiZariga, who works at Microsoft, has a great blog post to go through and talks about what the Azure Active Directory portal experience looks like in this new model, as well as some changes to the code. So it's not terribly difficult, and I didn't go into depth here because the concepts are not wildly different. There's just some little tweaks about the endpoint that you might call and some library references that you might set going forward. I fully expect those updates to be delivered through a Visual Studio update. Okay, and so that's our talk for today. Again, a little bit of background beginning here, a couple of demos to show you. I can then secure my web application, I can secure my service, and I can make a call to a secured service using the various libraries in .NET. I hope you'll come back in a couple weeks. We'll talk about some advanced Azure AD topics. We'll cover things like multi-factor authentication and some of the premium information there, information that's relevant to developers. You might make your applications much more secure. I hope this was helpful, and I look forward to seeing you in a couple weeks.